Our task is to find the volume of the solid obtained when the enclosed region y equals x plus 3, x equals 0, and x equals 5 is rotated about the x-axis. These functions denote our enclosed region. In order to visualize our problem, I find it helpful to graph these functions. This can easily be done by paper, but I used an online graphing calculator for simplicity's sake. To solve this problem, we will have to use the disk method because we are rotating a curve about the x-axis. If you remember from the course note page, we know that the volume of a solid generated by the summation of a bunch of disks is pi times the integral from a to b of f of x squared dx. So now let's find the parts of this formula. First, we will find f of x. F of x is going to be the curve that we are rotating about around the x-axis. Therefore, just by looking at this graph, we can see that f of x is x plus 3. Now we have to find the limits of integration. Again, the graph comes into use. We can see that these two vertical lines, x equals 0 and x equals 5, confine the function x plus 3. Therefore, a would equal 0 and b would equal 5. Now that we have everything, we can plug everything in. We get pi times the integral from 0 to 5 of x plus 3 squared dx. Using algebra, we can expand x plus 3 squared into x squared plus 6x plus 9. Everything from here on out should be pretty straightforward. We can now use the power rule to find the antiderivative. The antiderivative of this integral would be x cubed over 3 plus 6x squared over 2 plus 9x. If we plug in 0, everything would evaluate to 0. So we only need to in this case, we only need to plug in and solve when x equals 5. When 5 is plugged in, the end result is 485 pi over 3. And that is the answer to our problem.